Okay, let's look at this this next question here. We've got, I mean, first of all, just read through, obviously, but you know, you're going to be using the GRASP method. So what information is given here? Some of it doesn't matter. There's 3 teenagers, that doesn't matter. But there, we've got a total force of 350 newtons. Also ask yourself, what does the question require? In other words, what is it asking? Now, you can write down what's given and then figure out what the question requires, or figure out what the question requires and then get the given information. Sometimes you need to try just writing down the given and then writing down the required. Often I like to look and try to see, what is the question asking me? Okay, how much work? Okay, it's looking for work. Right off the bat, that gives me an insight, right? What formula I might use. What formulas have we learned that use work? Find work or find the joules. And of course, we know work equals force times distance. But yeah, let's see what we got here. Oh, we got a force right in the question, 350 newtons. They pushed the car 15 meters. Hey, we got a distance. So we're just reading the question carefully and just pulling out the key numbers. What information is given, what's required. Again, work. No, yeah, we don't know it. Too bad. Too bad the question didn't just tell me. Unknown number of joules. Always put your units. This is exactly how you need to write your answers, and exactly do it the same way over and over. Some analysis, in other words, what formula? I think we already know, but still go through that process. Make sure this is the right formula. Yeah, I need to find work. And I've got force right there, and I've got distance, so I'm going to be able to do it. Solve, plug it in. So plugging it all in, my force is 350 newtons. And I'm going to multiply that by 15 meters. Again, think about what they're doing. They're exerting, that's a fair bit of force, actually, right? That's not a super ton. It's not like they're lifting the car straight up. They're pushing it. And over 15 meters. So we're going to figure out how much work. I mean, what if they only had to push it a meter? That'd be different than if they have to push it 15. So anyway, 350 times 15. Let's get our calculator. Again, you definitely want to use, and you need a calculator for this. 350, let's say that it's newtons, times 15 meters, 5,250. Cool, there we go. There's our work. Work is equal to 5,250 joules. Work is energy. Energy is work. Now, just a point here. There's actually only 2 significant digits, so we can't actually get that exact. So technically, we would now round this to just 2, right? So it's going to be either 5,200, or we round it up to 5,300. So in fact, we would estimate this basically at 5,300 joules. And again, we only have 2 significant digits here, so that's why we can't get super accurate. If we had known it was exactly 15 meters, so literally we go 15.000, but we don't. See, it could be 15 and a bit, right? Could be 15 and it could, right? That's actually why we do this right here. Now we do our paraphrase. I'll accept either one, you know, as you begin the course. By the time you finish physics, you want to, with us in the Science 10, you got to get, you know, the answer right with the right, rounding it correctly. But quick paraphrase. So a sentence, it takes 5,300 joules to push a car 15 meters. Exclamation point. Okay, let's try another one next.